Good morning, good morning. I hope you are all doing fabulous. I'm glad to see, at least personally, that the weather is starting to turn up and that I'm able to get outside a little bit more. And I hope you all are getting outside, getting some exercise, but still being super, super, super safe. So, we are going to continue R4. And you were all expected to watch a video that reviewed the powers of exponents rules, which I use the tool MadSpum or MadSpasm, where when you multiply, you add, when you divide, you subtract, and when you raise a power to a power, you're multiplying. So, given all of that information, you're like, all right, that's fine. There's a few more things we need to add into this. And as you can see, all of the exponents on today's, or at least this first set of 4, are fractions. And you should be like, what? How can exponents be fractions? Well, they can be. So, what we're going to do is talk a little bit about these fractions. We're going to start with number 4 because, oh well, it's the easiest. So when we're looking at these fractions, the top number actually, if we're, see it, the directions say, write each expression in radical form. So what? We're now changing our exponents into radicals. That's what the directions is saying right now. We're changing our exponents into radicals because they're directly related. So the 1, the number on top of each fraction, is going to become your exponent. And the number on the bottom becomes your radical. Now, there are several different ways of rewriting this. So, you could do, in fact, if I do x to the 1/3, this can be rewritten as x to the 1 with a cube root over it. And remember, I said the 3 becomes the radical. It means it's hanging out here on the hook of the square root symbol. I could also rewrite this as the cube root of x to the first power. Both of these things are the same thing. It doesn't matter if our exponent is inside the radical or outside the radical. But what we need to keep in mind is that the number on top becomes the exponent, and the number on the denominator, the bottom, becomes the radical. So everything in here is going to be taken to the 1/3 power. So, given that information, the 1 becomes the exponent, and the 3 becomes the radical. Now, because there is a set of parentheses, everything. So, I put everything to the 3rd power, and everything goes inside the radical. Now, do I need to write my exponent? Well, anything to the 1st power is itself, which is why I kind of started with this example. It's because it's the easiest version. If I were taking something to the 1/2 power, it's simply going to be the square root because there's an invisible 2 that hangs out here. If it's the 1/4 power, it simply becomes the 4th root. If it's the 1/7 power, guess what? It simply becomes the 7th root. Easy enough, right? Okay. Oops, didn't want to do that. Okay, let's try some of the others. So again, the 5 becomes the exponent, and the 3 becomes the radical. Because they're parentheses, everything is going to go inside. So I think it's easiest to write my big radical, and everything gets raised to the 5th power. Now remember, mad spasm. When I'm raising a power, I multiply. But really, I'm not raising a second one to the power. What I'm going to do is I'm going to distribute this power. So if I'm doing it to the 5th root or to the 5th power, I could put it in my calculator, but it's 10. So it just means I'm going to add zeros. And in fact, there's going to be a total of 5 zeros. So again, 3rd root, and there'll be 5 zeros. 1, 1, 2, 3, 4, 5, and then r to the 5th power. I can add my comma back in there. So it is the 3rd root, the cube root, of 100,000 r to the 5th. Okay, let's try this again. Remember, the top number becomes our exponent. The bottom number becomes our radical. So we have the 4th root of 5x to the 3rd. So I'm going to distribute my 3rd power. That's not 5 times 3, which is 15. This is 5 times 5 times 5, which gives me the 4th root of 125 x to the 3rd. Okay, let's try another one. Should be kind of getting this part. And if you're having problems with the multiplying, use a calculator. There's this thing called Desmos. We've used it all year. I know, it's shocking. Please use it. Okay, so exponent and radical. So 4th root, 3a goes inside the parentheses to the 3rd power. Distribute. So my final answer is the 4th root. Now, this is not 3 times 3, which is 9. This is 3 times 3 times 3, which is 27a to the 3rd. Okay, that's the first part. Now we have to write them in exponential form. So everything we just did, we're going to undo. Okay? So as a reminder, with our fractions, it becomes the exponent over the radical. So what's inside of our radical is p. And it's exponent, so it's 3 over 5. And that's it. Okay, this what's inside of our radical? 10b, because there's 10b, we're going to put it inside parentheses. It's to the 1st power because I don't see any exponents. There's not an exponent inside, there's not one outside. So there's an invisible 1 hanging out here. And it's to the 6th power. By the way, I hate when they use the letter B because it can sometimes look like the number 6, and I apologize. There's not much more I can do about that. I just avoid the letter B. Okay, so again, what's inside the radical is 6m. Put it inside parentheses, and it is important that you put the parentheses. It will be wrong without the parentheses. I'll explain that in just a moment. Remember, it's exponent over radical. Now, why is it wrong if you do not have the parentheses? So if I were to write it like this, technically what this is being said is that the 4/3 only applies to the m and not to the 6. So what this is saying is 6 times m to the 4/3, which would put this 6 on the outside, which totally changes the value. In fact, it changes it by a power of 216. So it is very, very, very important that if there is everything inside the radical, it must go inside parentheses. All right, and the last one. So this is V inside the radical. Exponent is 7. Radical is 6. So this one's pretty simple. Okay. Now it's asking us to simplify. This is when we are going to apply the rules of our mad spasm with fractions and numbers. So remember, when we're taking a power to a power, we're multiplying them. So here what we're going to do is do 6 over 1 times 5 over 3. Now, if you are not comfortable with doing this, please use the Desmos calculator. I'd like to cross cancel. 3 goes into 6 2 times, and 2 times 5 is 10. Now, there is no longer a denominator here. This becomes our exponent, so this simply becomes k to the 10th. Okay, again, we're going to distribute our exponent. And we'll talk about 81 to the 3/2 power in just a second. But let's do 2 over 1 times 3 over 2. Again, there's a 2 both at the top and the bottom. They cancel each other out. We are left with 3 over 1, which is the same thing as 3. So this becomes n to the 3rd. Now let's talk about this part. Remember, I said that the numerator is to the power, the denominator is the radical. So we could do the square root of 81 to the 3rd power, or we could do 81 cubed and then do the square root of it. Now the interesting thing is, not interesting, I know what the square root of 81 is. I don't know what 81 cubed is. So I'm going to go with this option. The square root of 81 is 9. So now we're going to do 9 to the 3rd power. Remember, it is not 27 because it is not 9 times 3. In fact, what it is 9 times 9 times 9. So you should be using a calculator. I'm simply going to use my phone calculator because, oh wait, I can. 9 times 9 times 9 is 729. So this becomes 729 n to the 3rd. Okay, let's keep working on this. So this becomes 49 to the 3 halves. And then we're going to do this multiplication again. So this becomes 6 over 1 times 3 over 2. I prefer to cross cancel. My 2 goes into 6. How many times? 3 times. And then 3 times 3 is 9. So this becomes x to the 9th power. That kind of looks like an A. There we go. Now, let's focus on 49 to the 3 halves. This can be written as the square root of 49 to the 3rd power. I know what the square root of 49 is. It's 7. And so 7 cubed, or 7 times 7 times 7, is 343. So this becomes 343 x to the 9th power. And the last one. Excuse me. I get horrible spring allergies. Everyone thinks that I have the coronavirus because I cough. I don't. I just have spring allergies. Anyway, this becomes 49 to the 3 halves. Oh, wait, we just did that. Oh, good. I know that answer. And this becomes 4 over 1 times 3 halves. Okay, I'm going to cross cancel. The 2 goes into 4 2 times. 2 times 3 is 6. So this becomes p to the 6th power. And we've already determined that 49 to the 3 halves is 343. Okay. Last part is solving each equation. Yeah. And we've got some kind of complex solving down here. So, if I were to want to get rid of this 1/2, the easiest way is to multiply by the inverse. Well, the inverse is the reciprocal. So I'm going to multiply this entire equation by what's the reciprocal of 1/2, which is 2 over 1. Now, what happens is that when I do it times this, these two, all cancel out. So I'm left with k on one side, and then I'm left with 7 to the 2 over 1. Well, 7 squared is 49, so k is equal to 49. Same thing. We're going to do it to the reciprocal. So what's the reciprocal of 5/4? It is 4/5. So everything cancels out with the p, so we're left with p is equal to 243 to the 4/5. Now you have to ask yourself, Miss Wood, we do not know what's the 4/5 of 243. That's where Desmos comes in handy. So let's Chrome. Oh, so sorry. Okay. 243, and then you hit this AB button here, and then you turn it into a fraction here, and you can fill it in 4/5. Oh, it's 81. So, P is equal to 81. So again, this is squared, or 2 over 1, which is the same thing as squared. It cancels this exponent out, which gives me x. And then 5 squared is 25. Again, we simply multiply by the inverse, or the reciprocal, which is negative 2/3. So we're left with x is equal to the negative 2/3 of 1 over 343. Okay, so negative exponent means we're going to do 1 over, right? Yeah. So if I'm getting rid of my negative exponent, this is going to rise to the top. So I could simply say that it's 343 to the positive 2/3. And then again, I go back to my scientific calculator. $343, AB here, so it's our exponents, and then I hit the fraction, 2/3, and it is 49. Too far, there we go. Okay, same thing. 3/4. That leaves me with R is equal to 625 to the 3/4. And I can tell you that this is going to be, the 4th root of 625 is 5, and then cubit is going to be 125. And then the last one, remember we're doing it times the reciprocal, so k is equal to 729 to the 2/3. The cube root is 9, and 9 squared is 81. Again, just use your scientific calculator. What about these more complex equations? So the first thing you have to do is get the radical on one side by itself. So if you notice, the radical was on one side by itself with all the previous examples. So we're going to subtract 9 from both sides. That's going to give us negative 15 is equal to negative 5, x to the 1/2. Then we're going to divide both sides by negative 5. That's going to give us 3 is equal x to the 1/2. Then we simply square the entire thing. That gets rid of this, and 3 squared is 9. So x is equal to 9. Here, the exponent is on one side by itself because there are parentheses here. So I can now multiply by the reciprocal first. Gets rid of the exponent here, and 7 squared is 49. And then you can simply solve it the rest of the way. Subtract 1 from both sides, A is equal to 16. Again, this is a situation where the exponent is by itself, so I can simply get rid of the exponent first. That gets rid of it here, and 9 squared is 81, so I have v plus 29 is equal to 81. And to solve this the rest of the way, I'm going to subtract 29 from both sides. Should be 52. The last one is very similar to 23. So subtract 4 from both sides. That gives you a negative 36 equals negative 4 n to the 1/2. Divide by negative 4. That gives me a positive 9 is equal to n to the 1/2. Now that the exponent is by itself, I can square both sides to get rid of it. 9 squared is 81, so n is equal to 81. Okay, your work after now watching this and taking notes is going to be to practice on the next page, and it is simply going to be practice. I will give you the answers. I will give you an answer sheet that has my handwriting that shows how to do all of the steps. Easier to read than this. So that's not work. Then you have a 5-question quick quiz over this to make sure that you can demonstrate these skills. So please, the practice is up to you. It's how many you need to practice. If you need more practice, it's there. And then quick quiz, available for 5 questions. It'll be worth 10 points. It is going in as a quiz grade, so do your best on it. You have unlimited attempts to get it right, and your highest grade goes in the grade book. I miss you all. I hope you are well, and I will talk to you soon.